Needed to download in Docker a couple of 100 megabytes or gigabytes of stuff. So if you can make it feel free, just like check this out. You need bootcube or minikube. There's like two main setup or like two main ways to run the Kubernetes cluster on your local machine. Or if you already have like a Kubernetes cluster, of course you just need that the kubectl works, and then you should also be able to like apply all of the examples to your production or whatever cluster. The user containers will be up. I'm also more than happy to join the workshop later on and like go through this again, or like do this afterwards when the slides will be up and like these steps will be up, so you should be able to like test this and try this at home. Yeah, Prometheus. So SoundCloud originally was like a huge monolithic Ruby shop basically, so we had like one huge thing. Now we have like hundreds of services running, and yeah, we have now like lots of different workloads, heterogeneous workloads on every single machine. I mean, we all know this with Kubernetes. We have now like hundreds of different pods on a single machine, and we started to have like very short life cycles in our deployment. So suddenly, people started to deploy every, I don't know, multiple times per day instead of like our old Ruby application was definitely a bit slower. And we definitely reached the limits of our Graphite setup. I guess we could have spent a lot of time to scale Graphite and make it possible to scrape or like to monitor so many targets which are like constantly changing and going up and down. But all of that seemed a bit lacking to us. So this was like the main motivation. The other part we were looking for is like way more insight than what we had before with our old setup. So for one, we use DATSD and Graphite already, but usually only on a per service level. So like every instance we are pushing some counters up, or like we got more requests, but we only knew, okay, this whole service has like so many requests or like errors, but we couldn't really drill down into which instance is it, which version. We wanted to like drill down into like any kind of labeled, or like label setup basically. And what we also had on the other side was like the old software as a service stuff, like New Relic and pretty much only New Relic and Airbrake, but that was not running on all our systems. Like in the old Ruby application, we only ran New Relic on a few of them because it was too expensive otherwise. So we never really knew across everything. We either had like very broad metrics for the whole service, or we had very detailed one for a single one, but we didn't really have like statistics. And trying to do this with Graphite, we just constantly killed our Graphite setup by like trying to like add too many labels basically to the Graphite paths. So we knew we needed something else. And our alerting up to that point was like pretty much dangerous, and yeah, some black box monitoring tests. Who doesn't know the difference between black box and white box monitoring? Okay, cool. So we only did like, I had like these black box tests, but we never really had like any alerts on trending. We started to do this with Graphite, but again, all of this was pretty lacking. So yeah, and the last big part is like measures. I mean, I guess if someone is really experienced with its config, then you can make it work for, I don't know, bigger setup as well. None of us was really, our developers constantly complained about like too much noise. We had like lots of default measures alerts, which are like more coarse than like a symptom. It was more like, hey, the MySQL database is down, but it didn't really matter that much because the service was like immediately taking it out and wasn't really using it, but still someone got paged. Yeah, and it was not so much like a symptom-based monitoring where you know, okay, the 500 rate is high, there's really something which impacts users right now, and we should work on that. So that was something where we knew we needed to like completely overhaul our alerts, and needed like a better system for that, and more so grouping and like flexible silencing, which in Nuggets it's really hard to build a tree where you can say like, okay, if this is down, all the other stuff should also not send me a page, or like vice versa. With like the label system we have now Prometheus, or like you might be familiar from Kubernetes, it's like a lot easier to just like define exactly what you want to match. Like all these alerts which match these kind of labels should be silenced and you don't need to like build up some trees where there's some dependencies between them. To give you an overview of how Prometheus looks like, or the rough architecture for the people who don't really know it. So one design goal was to have it like to be as resilient as possible. So there is like only one single binary. That's the server in the middle. It writes to disk by default. There is like a lot of work on long-term storage right now. It will be possible to, well, it's already possible to push your metrics on somewhere else. But by default, we want to be able to just like have this single binary, put it on any machine that could even be a development machine, start scraping it, starting it, and it will like go to your targets and like collect metrics, and it's working. So even we explicitly didn't want to have like any consensus in there, or like a ring of multiple or cluster of multiple Prometheus instances which need to communicate, because if your network is down, you don't want to have like these kind of dependencies. It should always work. So if there is a machine which is working, then you should be able to have like monitor. This was like one of our main design goals, so that's then the reason why we have like a single Prometheus server in the middle. By default it writes to disk, and SSD is definitely something you want to have if you set up Prometheus with rotating disk. There's a lot of code in the storage to like take care of like the old slow disk, but yeah, use an SSD and then you're more or less fine. So with a single server you can, or the record is like scraping 800,000 samples per second, which means like a single data point per second, and you can store like millions of time series. So there is, I mean, we have like our bigger machines with like, I don't know, 800 gigabytes or terabyte of this. We can store months worth of data about like all our machines, for example. For node metrics, for example, we have like example of one single machine. I mean, there's a couple of them to like for HA, but you just like replicate it. That's the story in Prometheus to like have like high availability. You just do the same thing twice. And there is no communication in between the two servers whatsoever. You just have like the same server twice, you configure it exactly the same way, and they both go to all the targets and like scrape it. So yeah, when I talk to target, that's the left part here. So it pulls metrics. Yeah, that's actually one, I guess, huge controversy in the monitoring ecosystem is like pull versus push. You will find a lot of information about that in the internet. We decided pull. It has like a lot of advantages. So the Prometheus server knows, or like it uses service discovery, as you can see there on the top. You use service discovery to discover all your services on the endpoints it should like go to and collect metrics from, and then it opens a connection. It's a normal HTTP connection, goes to the target, usually on /metric. There's like every of the targets are listening, and they return the result. Actually, can show an example. So that's for etcd. If you go to like an etcd server, can I show the tab? Okay, just believe me. So it's like some IP at the port, and then /metrics. And this etcd server is like returning metrics now in the text format. Prometheus also supports protobuf, but in the end, it doesn't really matter. And that's what you can see. So one example, for example, one advantage of this pull model is like you as an operator can also at any given time go to any given of your instances and go to /metrics and see what is the state right now. So the Prometheus server uses, yeah, we have like probably a dozen of different service discovery support right now. The Kubernetes one I will talk about today. DNS, SRV records or A records was like one of the first ones. So if you have like a DNS setup, then that's all you need. You can also just like write them statically in your config file, of course, if you don't have like a big setup. Or yeah, there are lots and many custom integrations. Yeah, the push gateway is like if you have like batch jobs which like don't really live that long, that like the Prometheus server can go there, then of course we need a solution for that. So they just like push it to the push gateway, which is really just a cache. It's not an aggregator, it's not like Statsky, it's just a cache for the metrics from like one short-lived process which was running somewhere. And that's like the way how you can monitor, for example, the runtime of Hadoop jobs, or I don't know, if you have Chef running and the Chef client is like running for like, I don't know, a minute, and then it's done, it can at the end of its run push some metrics to the push gateway. The other parts of the ecosystem are like the alert manager. I won't really talk too much about that today. But yeah, all the Prometheus server then send or push their alerts to a single alert manager. You might ask, like, why is it like an extra component? The reason is, like, as I said, for HA, you usually set up like 2 servers, and then both of these servers will send the same alerts to the same alert manager, and then the alert manager will like deduplicate it and only send you one single notification. Or if you want, for example, you have like different alerts which all reach the same team from like different Prometheus servers, like one is for MySQL and the other is for Memcached, and the third one is a team-specific one, then you might want to send them only a single alert if something big is going on, so you need one component which can like aggregate all these alerts. So that's the reason there's like an alert manager. This one got recently completely rewritten. It's like HA. Yeah, it's not actually in this picture yet. So there is like usually you deploy like 3 to 5 alert managers, which are stateless in itself, and will then ensure that if one single alert manager process dies, you will still receive alerts. Yeah, and then there are a couple of integrations for like UIs. Grafana I will show today. We used to have Pondish, which was something we built before Grafana was out, but it's like discontinued. So basically what you will need is like a Prometheus server, an alert manager, Grafana probably, and then start to instrument your services. Yeah, to give you some examples, so that's like an part of the metrics I just showed you from the etcd store. So in the text representation, there's always a help string, which is not, I mean, it's not really mandatory, but I mean, you should always use it to like describe what this metric actually is about. In this case, it's etcd store bytes. You see this underscore total, so one big thing in Prometheus, given that it only comes, I don't know, every 30 seconds, or like there's this great interval when it goes to your targets, is you don't want to export gauges, but counters. Why, you might ask? So if you, I don't know, at the beginning, at the first great time, you had like 20 connections right now at the server. And the next time the server comes, it's again 20 connections. But in the meantime, there was a huge spike and something was happening. There were like 1,000 connections, and your connection pool was filled up. You don't know this if you just export like a single, what is the state right now information. You should always export counters wherever possible. And then use functional Prometheus to like calculate the rate. So in this case, it's a counter, and like all these numbers will always go up. So if you just plot, let's see, the store bytes total, like we can do this later, in Prometheus, you will just see like a line which goes up and up and up. Then you want to use a rate, which then calculates, okay, what was the difference in like the rate of the last minute, or the rate, rate is usually per second, but like, so a per second rate over like the last minute, what was the average? And then you're able to like see these spikes, even though your Prometheus server comes only every couple of, I don't know, 10 seconds, a minute, whatever straight interval makes sense for you. And another big thing you see in this example is like the labels Prometheus uses a lot. So you're free to like attach any kind of labels to your metrics. In this case, we want to know for which, what kind of byte it works. So we have like an action label here, and then like a set or create or compare and swap, like different actions which were made, and we have like the counter for each of these. The nice thing of like labels is like you can easily sum them up. And the last one. So for example, if I just want to know for my instance, what is the total amount of bytes that I've seen over on average over the last minute, then I can do this last query and say like, hey, okay, first I need to calculate the rate over this, and then I aggregate these and sum them up and remove the action of that. Which basically means now we will have like a single value out of that, which we can do this later in the example. The other, the second one, you see, you can then, of course, use a label selector to say, like, hey, I want to know only the set bytes to the store. What is the rate of that? There are, of course, then also regular expressions to match, like, other multiple values at once. Or, also very powerful in the Prometheus query language, you have, like, you can, like, easily divide. So it's not an SQL-like by purpose. so that you can easily do things like divide this vector by the other one, for example, this case. So everything in Prometheus is a job. Well, a job is a group of similar targets. And then you want to know, okay, how many of my instances are down? You only need to write, if you write this expression, you know per job how many of my instances are down. So in a percentage. So it's up is 0 means okay, there's an instance which is down. I divide this by the sum of all instances, and I know the percentage of how many instances per job are down. And then you can easily just put this in an alert, and as soon as say, okay, as soon as I don't know, more than 20% of my instances are down, which should never happen, I want to get at least some kind of notification. And you write this one single expression, and it will work for all jobs. You don't need to touch this again. If you add a new job, the same expression will work as well. To explain why I come to configuration, I wanted to make this a bit more practical here. So all of this is explained on the Prometheus IO. There are the docs. You will find all of what I'm talking about today also on the page report. By default, a Prometheus configuration consists of 3 big parts. Some global settings, for example, the default scrape interval is 1, or a common one. Then you define the scrape configs, which means basically what kind of jobs do you have, and how can Prometheus discover your instances, and some root files. We won't really talk too much about that. So in the end, you can imagine if you have millions of time series, at the end you just scrape, and then you're calculating the sum out of it. That of course takes some time because you need to go over potentially thousands of time series just to come up with this one single value for your overall error rate, for example, for your service. And you want to plot that on your dashboard, so you're always asking for this, give me the aggregated number, so it's easier to just calculate it as soon, so the same rule will also evaluate it every 15 seconds, and or the same expression. So for example, any of these expressions could be evaluated every 15 seconds, and then you only need to ask it in your dashboard for this pre-calculated metric. So that's what basically rules are for. It's kind of a caching, and then the alert definitions also happen in the rules files. I will show some examples for that later. And these are 2 example job configurations. So the etcd one is probably the most simple Prometheus configuration, job configuration you can do. You give it a name, you say, okay, I want to scrape etcd, and you just statically put the address of your etcd server in your config. That's probably not something you will do in production. I'm not aware of a single configuration at SoundCloud which does that, but for the beginning, it's of course nice to just be able to put something statically in your server. What you really want to do, though, and what I will talk about, is use a service discovery so that you just define how Prometheus can find your targets, but you don't specify them, and Prometheus will just constantly go to the service discovery of your choice and ask it for all the instances. So in that case, it's actually a bit complicated, so that's what this talk is about. In Kubernetes, we don't want for every single service to replicate these kind of job definitions. So we just say okay, I want to scrape Kube components, everything which is running on Kubernetes. There are different roles of the Kubernetes service discovery. It takes a bit too long to explain that, so go to the Prometheus documentation, you will find it. One thing in Kubernetes is endpoints is basically a set of pods. Who does not know what a pod is in Kubernetes? Okay. Okay, I'll skip ahead and go there. To explain some components of the Kubernetes, I guess it just makes it easier to understand it. So in Kubernetes, the single scheduling unit is a pod. And a pod, so you all know containers from Docker, and the pod is basically a group of one or more containers. You might ask hey, if I'm not scheduling a container directly, there are often situations where you want to make sure that multiple containers are co-located, so they're at the same place, and if the whole unit should only be available if all containers are available. One big example for that is, for example, sidecar. So you have your main application, and then you have some reloader, or you have something for Prometheus, for example, you have something which extracts metrics from it and exports it into the Prometheus format. or for databases, you have like some job which is configuring the database. So in all these cases, you want to make sure that these containers are always scheduled together, so that is a pod in Kubernetes. And yeah, that is the concept of containers. I mean, it exists, but you can't schedule a container. You can only schedule a pod. The service is then the logical set of pods, so you say like, hey, these all form, I mean, all the pods matching for this name, for example, or like, I don't know, app foo, they form one service, and then the service gives you like access patterns of like how to access that. For example, like a common IP, because so you have like just the service IP, and you can always go to that. Cool. So in this example, we just scrape basically all the endpoints, so it means all the pods of the service, and we do some relabeling. And yeah, everyone who starts with Kubernetes and Prometheus, you will definitely come to the point where you need to understand relabel configs. It is a bit complicated. That's why I wanted to talk about this today. So basically with relabel configs, Prometheus provides a generic way to do whatever you do in your organization with Prometheus. I mean, there are like so many different ways how people want to configure their jobs, how they name things, and we quickly came to the point of like, okay, our configuration would become like super long to accommodate for like all special cases how people do their things. So we decided we will just like extend the label concept we already have in Prometheus and give you means to like change, filter on given labels and say like which labels of Kubernetes, for example, you want to have in your system. So this is the first example. The Kubernetes service name, we provide them then as a meta label and say like, okay, if for every Kubernetes service name, if it's matching cube something Prometheus discovery, then we want to scrape that. So everything which does not match this regular expression will not be considered, it will not be scraped. So that means we can just say like, okay, by default, the Prometheus service discovery will ask for everything which is in Kubernetes, but then for all the services which don't match that label, we will ignore it again. So that's like one of the huge parts of like relabeling is the action key to like define that also drop as a counterpart to say like, okay, I only want to consider targets found by the service discovery which match things. There's a second one. Pods can have a pod name. So we are, in this case, for like this example configuration, we are only considering the pods which have a pod name called Prometheus. So everything which is not named Prometheus will be ignored. Because I mean, if the pod name doesn't provide Prometheus metrics, then we can't really do that much about it. So these are two ways to say like, okay, I came up with my company with some naming patterns. Instead of Prometheus, you could say metrics, or you could say whatever, company ABC metrics. So whatever your kind of naming is, with like these regular expressions and like this relabeling and these meta labels, you're very flexible in expressing how you want to define your infrastructure, what your standards are, and what Prometheus should at the end scrape. And yeah, another common one is like to replace it. So if you remember, I said the job name was just like Kubernetes components. That's actually not very useful because we will have monitor like many different kinds of services inside of Kubernetes. So we want to have like a better job. So in this case, we call it service. We say like, okay, we take the service name from Kubernetes and we use that as a Prometheus job label. So you're able to like, you're also then free to like, job is already taken, I mean, it's already provided by Prometheus, or it's a label which is known to Prometheus. You're also completely free to say, let's say you divide your infrastructure in regions. Another one uses zones and says like, no, I don't have a region, I have a zone. And another one says like cluster. So you're able to just say like, hey, I want to have a new label called cluster, and I take that part of Kubernetes in this case and use that for my label name. So you're very free with like these replace relabel configurations to say like, okay, that part is something I want to have in everywhere in my metrics, or that label is something I want to have everywhere, but I don't care about other labels other companies care about. Is this clear? Are there questions to relabeling? Which is like, I mean, it's one of the biggest confusions, I guess, for people who come new to Prometheus, because it's fairly complex and it's also YAML, and like people are like, I can't read this. In the end, it's actually not too complicated if you, just see it from the, you have some source label which is provided by Prometheus. I will show you how you can find out all the source labels. You can define some regular expression, and you say like either I want to keep that or drop that, or I want to like use that information and include it in my metrics. Oh yeah, so that was actually one of the things. So also in the same case, only for the stuff which matches the Prometheus account. I guess in this case actually that's a bit redundant because we dropped everything else anyway. So like things which do not match the backups would never come that far. Okay, before now we'll go into the workshop, I guess a few things about Kubernetes needs to be said. So like pod and service, a deployment for everyone who has never worked with Kubernetes is basically the declaration of like, hey, I want to have these kinds of pods, and I want to have some, I don't know, that many of them, so I want to have 50 pods of the exact kind. That's a specification for the pod, and here is a strategy how to deploy this. So that's basically a deployment. It's a very declarative way of doing your deploys, and Kubernetes has the implementation to just do whatever you ask it to do. So it's a great way. It was added a bit later in the Kubernetes development, but it's the de facto way how to do deployments of Kubernetes. Then the daemon, path, and replica sets. You don't really need to know too much about it. It's basically different ways for Kubernetes to tell it how to group pods. A daemon set, for example, you're telling Kubernetes that on every single machine you want to have exactly one pod. Path sets are for stateful services, like Prometheus, for example. We will use a path set for that. A path is basically, if you haven't heard of the cattle versus pet analogy, it's basically, okay, a path is something you need to take care for, like a snowflake, and all your standard application metrics instances are just a replica set. So you just tell it how many you want to have of it, and then Kubernetes will find free resources and deploy it. And the last part I will use today is like a config map. Is basically a way in Kubernetes how you can give configuration data for files, and these files will then be mounted in as a mount inside of your pod. It has of course some drawbacks, but it makes some things also easier if you don't need to like build a new image every time. Cool. With that, finally coming to the workshop. So I have my Kubernetes is running in a very I use bootcube here, so I have like 2 virtual machines now running on my system, a third virtual machine doing something else. And at the moment, all pods which are scheduled are just like Kubernetes internal pods. If I now go check. Oh, I also have like so there is a dashboard for Kubernetes, which basically shows you the same information I just showed. So in all namespaces at the moment, these are all the pods which are running. Is that too small? So it's like, some controller manager. You don't really need to know too much about the Kubernetes stuff. It's all internal stuff, like DNS and providing all the services for Kubernetes. Sorry. So as first step, I want to install Prometheus. For that, I just say deploy, and it has created something. It will take some time until this is done in Kubernetes, so I will take the time to show you what I have done here. So there is a very new way in Kubernetes, or in Kubernetes, how to organize your Prometheus. Either you have a couple of different ways. So what we need is pod specification. The pod specification is basically, okay, I want to have one container. You tell it which Docker image you want to run for Prometheus. You want to tell it on which port it should listen, like all the standard stuff you're doing if you start or define the Docker container. So that's all built up in a pod specification. So to run anything in Kubernetes, we need this pod spec. Then we have like some configuration, and we want to like load this configuration and tell Prometheus like, hey, that's the config we wrote, please use that. And we need a server specification because we want to access Prometheus on a stable IP. Hops can go up and down at any time, but you want to have like a stable IP which you can like, I don't know, add to your DNS or whatever, so that you just have like one stable way how to access your Prometheus. So that's what we need. That's pretty much what you need for like any kind of service you want to deploy in Kubernetes. And we have a couple of different options. So for one, all these specifications in Kubernetes are JSON or YAML or whatever, so you can just go and write everything from hand. You will find countless of blog posts and examples on the internet how to do that. If you have like a very specialized setup in your company, then it's probably the way to go for you because you know already exactly how you want to do it. But that's not the case for most people who just start working on it. Then there's a new project, Helm, was started by Days, I'm not really sure how to pronounce it, and now it was moved into Kubernetes, if I'm not mistaken. So that's basically, so if you start with Kubernetes, definitely check that out because that's a bundle of a package specification. You don't need to write all of this, someone else has done it for you. You just like Homebrew, if you use that, or like any other kind of package manager, you just say like, I want to have that thing, and someone has done all the hard part for you. So you can do that as well. There is like one for Prometheus in the work, in this pull request. And a very, very new version how to do that, which only came out yesterday, is like CoreOS about like an operator, which is basically a thing which will run in Kubernetes, and you just then again declarative in a declarative way tell it like, I want to have a Prometheus with this specification, and that operator will install this Prometheus for you and will configure it and will do all the hard work for you. So you just say like, I want a Prometheus in the version 1.3.0, and you're done. And the operator will do all the rest for you and like create all these specifications and manifests and upload them to Kubernetes and take care of that. So I believe there will be also like a Helm chart for that at some point, or like soon, or they will merge their efforts. So that's probably the way to go soon enough. Yeah, check out the blog post. It just came out yesterday. I saw it 2 weeks ago and thought like, hey, that's cool. I can just like simplify my whole setup. And yeah, that's what I'm going to use. So that's basically the setup of the Prometheus operator. So there is like this operator thing. You don't really need to know too much what it's doing. It's just like looking for a Prometheus specification and the service specification, and then deploys and manages the server for you. So you don't need to do anything. And that's basically the first thing I installed. So I said like, hey, cool, I want to have this Prometheus operator. I get it from CoreOS Prometheus operator. I gave it some resources, and that's all. As you can see down here, so now this deployment was created. And if I reload this page, I should see there's the operator one. The next thing, so this was all I did here. The other thing I did is like I uploaded this specification for Prometheus server. So you see it's like, it's a different kind of API version, so it's like a Prometheus kind. So I specify I want to have a Prometheus server. It should be called K8. I just use the default specification, which is like, the operator will then always be updated to use the latest version of Prometheus or whatever, but if you want to use something special because whatever, then you will be able to say, for example, something like 1.2.0. And now the operator will make sure that your Prometheus server will run exactly this version. And I uploaded, the third thing was I uploaded the configuration file. So that's what we have seen before. There's like some, is it too small? Can you read it? So there's like some global information. So I told Prometheus how often I want to scrape it. Ignore the root files, we don't really need them for now. And I defined some Kubernetes configurations, which with the relabel configuration you're seeing here. So like, I only take the ones which have the name Prometheus for now in the service name, and I use that as a job label. And I also tell it if it's Kubernetes, then I want to use HTTPS. you can look these up later. Which means I should now have my Prometheus server. So I have a Prometheus server running with exactly this configuration, and yeah, it's scraping some targets every 15 seconds. And in this case, as I said in the relabel configuration, at the moment, only which matches the regular expression Prometheus, there will be only a single target. Yeah, and now we could start using the metrics. For example, there's like one metric with a load info, which gives us some information about the Prometheus server itself. Then we can check like how many samples the Prometheus server is scraping per second. It's like, yeah, 400 right now. So 400 different information, and so on. Yes, I don't have too much time anymore. Going on. So having the Prometheus server itself is not really too helpful. Usually you want to know at least about every single machine, like what is this, what is the CPU usage, what's the memory usage, what is the I/O, what is network throughput, all of these standard information you get from pretty much every single monitoring system. In Prometheus, we call that a node exporter. Yeah, it has nothing to do with Node.js. It's just, it could be a virtual machine or a physical machine, so we came up with like Node as the most generic word for that. And what we said, like Damon said, I talked about earlier, so we have like now a Damon set of a node exporter. This node exporter there should be one node exporter on every single machine. And from now on, if you add like a new machine to your Kubernetes cluster, there will be immediately a new node exporter being scheduled on it, and its metrics will be automatically scraped because we updated the Prometheus configuration to tell it scrape all services which are called Prometheus or which are called node exporter. So hopefully it will be done. Then I go to this page. Yep. You see my two virtual machines running on my machine here. If I were to add like more machines, or like real machines in your case, or more virtual machines, then automatically these things will be pop up. So you don't need to do anything. You get like a label for free with the instance name where it's running. In this case, I can even click on it and see directly, as I said earlier, what are the metrics this node exporter is like exporting. For example, CPU. So it gives me like what is the current CPU usage. Yeah, unfortunately, we can't really use a counter. The kernel doesn't give us counter values. Oh no, these are actually counters. So these are all counters of like the CPU usage, and I can now graph my CPU usage. I will show you some examples later. Going on. So that's all cool. Now we can like monitor the Prometheus server itself and all the node exporters. But we really want to know is we want to scrape the Kubernetes infrastructure itself. So we know like if something is broken with Kubernetes. So yeah, you see like quite a lot of stuff was installed now. We want to know some information about the controller manager and about the scheduler to components of Prometheus, of Kubernetes. We want also to have queued state metrics, which is like an extra exporter, which gives you information about like how many pods are running right now. That's something which that isn't really provided by any Kubernetes component itself. So someone wrote this queued state metrics exporter, and yeah, we reconfigured the server again to tell it. Cool. We want to scrape all servers which are called Prometheus or node exporter or Kubernetes state metrics. There's another group. It takes a bit too long to explain this, but you saw this example earlier. Also, everything that matches this kind of regular expression, please scrape it as well. We have a few differences in the relabel configs. That's why we have a second block. But in the end, it's both the same. It's like both the Kubernetes services copy, it goes going to Kubernetes, taking a lot of all the information and showing them. And if I reload my page, I get now all this information. And again, if like any of these pods get rescheduled, because of Kubernetes services copy, Prometheus will automatically find it where it is afterwards and like start scraping it again. So you don't need to that it won't be any need for like changing a configuration or anything. So yeah, now we are like scraping the information about etcd, about the controller manager, all these different components of Kubernetes itself. So now it would be cool to like finally get some dashboards. So we use Grafana for that. It will take some time. I guess I will just go on. Cool, I skipped a bit ahead now to like, I just deployed everything I have prepared here. Again, you can like do all these steps one after each other, like see what has been changed, look at the diff, try to understand what I did there, and see how you start to like scrape your full Kubernetes cluster. I should now have Grafana running here. Not yet. So yeah, sometimes it takes a bit until Kubernetes converges. There's a Grafana running. Oh well, I'm running a bit out of time. I guess I will just continue at the workshop and like show also like in detail then a bit more what I've done here. Okay, now I can't show you all the dashboards. Oh well, I will go on. So that's all what we did. Some practical examples, yeah, now I wanted to show you some dashboards. That's one of the dashboards that's actually taken from SoundCloud. So yeah, if you have like seen Grafana, that won't be something too new for you. This is like one generic dashboard, so we use now, most of our applications use a JVM. We have like a JVM kit which provides like some standard metrics for, if you use that framework basically in your application, and almost every service is doing it, then you have like a standard set of Prometheus metrics. All of these get then scraped in the same way, so we just like have like one of these config blocks and all of them get automatically scraped, and we can then build a Grafana dashboard where we have like our labels, which are like from which Prometheus server I want to get this dashboard, and then common labels we use at SoundCloud, like the system and the job. In this case it doesn't really make too much sense, but okie dokie doesn't make too much sense either. So people can just like, if they deploy a new service, they automatically have like one dashboard which is already built. They don't need to do anything. Automatically, the application gets scraped. All the metrics get collected by a server. They have like one common dashboard. They have like common alert definitions in the Prometheus. So it's really monitoring with batteries included, basically, where people can focus on the application and don't need to like redo things of like, I want to get an alert if my 500 rate is high. There are like some other couple of dashboards I wanted to show actually. So Grafana has by now a dashboard repository basically where you can download and include your dashboard. I wanted to do this live, unfortunately I don't have the time. But what you get from them, if you just want to start, for example, this is for Kubernetes, you could have seen that I could have just like clicked on install this thing and boom, I would have a dashboard showing me the current state of my Kubernetes cluster. So yeah, everyone can do this, pretty easy. You get then automatically the memory usage and the CPU usage for free. There are tons of other dashboards in at Grafana.net, so check that out. Same for like the node exporter. Yeah, I'm running out of time, unfortunately. Yeah, and I guess with that, one of the last things I would like to say is like two very good resources when it comes to monitoring, but then also the site reliability book is like for any kind of good practices or best practices, how to manage your infrastructure. I can greatly recommend that book. It's, if you don't consider yourself as an SIE, this still has like tons of valuable information. Definitely check that out. For alerting, one really good one is like my philosophy on alerting from Rob Evershook. Sorry, not really how to do it justice. Yeah, check that out. I will put up my slides as well. But if you Google for my philosophy on alerting, you will immediately find that. Also have like tons of best practices how to set up your alerting and monitoring and how better not to do it. Prometheus basically incorporates most of these thoughts, and like if you use Prometheus as the alert manager, then most of this stuff will feel very natural. And with that, thank you for listening.